Dear learners, today we are going to see about sine wave generators. A sine wave generator is an electronic device that produces a continuous waveform with a uniform frequency and amplitude. It is often used in the testing and analysis of various electronic systems. For example, in the field of telecommunications, the sine wave generator is used to produce a stable signal for testing communication channels. It helps to ensure that the signal transmission is reliable and free from any distortion or noise. Similarly, in the field of physics, the sine wave generator is used to demonstrate the principles of wave motion and interference. It can produce different waveforms and frequencies, allowing students to visualize and understand these concepts more effectively. There are different types of sine wave generators, and one of the most common is the RC sine wave generator. RC stands for resistor capacitor, and this type of circuit generates a sine wave by charging and discharging a capacitor through a resistor. The time constant of the RC circuit determines the frequency of the generator sine wave. There are two basic configurations of RC sine wave generators. First one is RC phase shift oscillator, and second one is Wein bridge oscillator. The phase shift oscillator uses a feedback loop that employs a combination of capacitors and resistors to produce a sine wave. The Wein bridge oscillator uses a bridge circuit to generate a sine wave. The basic RC phase shift oscillator circuit consists of three identical RC stages, each made up of a resistor and a capacitor. The output of the third stage is fed back to the input of the first stage, forming a closed loop. The three RC stages provide a total phase shift of 180 degrees. In this circuit, assume that a small initial signal is applied to the input of the amplifier. The amplifier amplifies the input signal and sends it to the first RC stage. In the first stage, the capacitor charges up through the resistor. The time constant of this RC stage determines the phase shift of the signal. The output of the first stage is then fed to the second stage where it undergoes a further phase shift. The output of the second stage is fed to the third RC stage where it undergoes another phase shift. The output of the third stage is then fed back to the input of the amplifier, completing the feedback loop. The three phase shifted signals are then combined at the input of the amplifier to produce the output signal. The basic Wein bridge oscillator circuit consists of an operational amplifier with two resistors and two capacitors arranged in a bridge configuration. The bridge is designed to provide a feedback loop that enforces the input signal leading to oscillation. In this circuit, an input voltage signal is applied to the non-inverting input of the op-amp. The op-amp amplifies the signal and sends it to the bridge network, which consists of two resistors and two capacitors. The frequency of oscillation is determined by the values of the resistor and capacitor in the bridge network. The output signal is taken from the output of the op-amp, which is connected to the junction of the two capacitors in the bridge network. I hope this video is useful in understanding the RC phase shift and the bridge oscillator. Thank you.